Hello everyone, how are you doing? I was asked to solve practice problems and using technique of integration. The first problem I'm going to solve is the antiderivative of dx over x squared square root of 25 minus x squared. And the first thing that comes to my mind, use substitution as a chain rule is not easy. Applying to inverse trig, I don't see it easy. I don't see it as a partial fraction decomposition, but what I see in here, I see something like cs squared minus a squared, by c being 5 and a become x. Therefore, remember what we said, if the derivative of inverse trig function is an algebraic function, we should be able to change the algebraic function to a trig function, and from there we go ahead and solve integration and switch it back to algebra. Therefore, if this one c is 5 and a is x, this would tie to a right triangle, which this is 5. Between these two angles, I'm going to pick alpha. And when we do trig substitution, we either going to use sine or tangent or secant. And because this is constant, my x either go here or here. If I put it opposite, I can use sine. This is x, therefore this is nothing except this side is square root of 25 minus x squared. And right now, I use this triangle to solve for that most complicated part of my problems. And I would say cosine of alpha equal to the square root of 25 minus x squared over 5. And by moving 5 in here, I can easily substitute the square root of 25 minus x squared by 5 cosine alpha. I have to, the most important part is the variable of integration. I have to look at this triangle and use one of the trig function that it allow me to solve for x, and from a dx, I find the differential. And this one, I'm not going to use tangent because this one is opposite over adjacent, therefore I have x over this, and it's going to be very hard to find dx. And I'm not going to use cotangent. I'm going to use either sine or cosecant, but sine is a lot better because it put my x on the top, and then it allowed me to move the 5 as a cross product, and it give me the x. This is very important. That's, I sometimes call it helping equation, because this sometimes help me to give me my dx, which is 5 cosine alpha d alpha. And sometimes when you have sine of alpha equal to x over 5, if someplace you have the integral of 1 d alpha and you try to solve for alpha, you can use that one to solve for alpha, which is arc sine of x over 5. Therefore, for solving for alpha and dx, this equation is extremely important. Okay, then I go in this problem, and I said instead of a dx, I put 5 cosine alpha d alpha. Instead of square root of 25 minus x squared, I put 5 cosine alpha. And see how easily this cancel? But don't forget I have x squared in the bottom. And what is x squared in the bottom? Is 25 sine squared of alpha. Therefore, I took care of my x squared, I took care of my dx, and I took care of that one. This and this is gone. 25 can come out in the denominator, and 1 over sine square is cosecant square of alpha d alpha. I don't know any trig function that is derivative cosecant, but I know a trig function this derivative is negative cosecant, and that's the cotangent. Therefore, I put a negative here and I put a negative right here, and that answer is become negative 1 over 25 cotangent of alpha plus c. And see, easily I'm going to look at that triangle right here, and I'm going to change my cotangent of alpha back to x, function of x, minus 1 over 25. Cotangent is adjacent, that's the negative, over the opposite, plus c. Don't forget that's 25 minus x squared. And see, this function right here is derivative is that function. 1 over quantity x squared times the square root of 25 minus x squared. Therefore, they asked me to solve that problem. That's one of the problem. The second problem I'm going to pick is going to become x cubed square root of x squared plus 4 dx. If this one was an x power of 1, I can easily use u substitution, but it's not. But in here, I see a squared plus b squared. Therefore, I'm going to go to a right triangle, and I said this is alpha. My a is x, my b is 2, and this hypotenuse is x squared plus 4. Therefore, my hypotenuse is that is square root of x squared plus 4. Somehow I have to solve for that is square root of x plus 4 and isolate it and write in terms of a trig function. And this is nothing except this over this. I want to make sure put this one in the numerator that I can easily solve for it. I'm not going to use cosine, therefore I have to flip it. Therefore, I'm going to say secant of alpha equal to a square root of x squared plus 4 over 2, but I'm going to put my 2 right here. See, I find the most difficult part. Right now, I have to find something to help me my dx and x cubed. Therefore, this is nothing except the tangent, because a square, a opposite adjacent always deal with tangent. Therefore, I'm going to say tangent of alpha equal to x over 2 and put my 2 right there. Therefore, what is my dx? Is 2 secant square of alpha d alpha. And what is x cubed? X cubed is 8 tangent of cubed of alpha. Then I'll go in here and I'll put 8 tangent cubed of alpha. Square root of quantity x squared plus 4 squared is 2 secant of alpha. And dx is 2 secant square of alpha d alpha. In here, I have a 2 here and a 2 here, 4 and an 8 is a 32. And I'm going to have 3 secant, 3 tangent. And the beauty about this one is that both power are odd. And I know a trig function that is derivative is secant times tangent. Therefore, I'm going to take one power away, and I'm going to leave this one for my du. What is left? It left secant square, because I took one away, but tangent square have to be changed to something that is derivative is this. It had to be changed to a secant. I already took one tangent away. I left with tangent square, and tangent square is secant square of alpha minus 1. Right now, see, I have secant to the power of 4 alpha minus secant square of alpha. Both of them, the derivative is secant of alpha, tangent of alpha, d alpha, and I have a 32 outside. Therefore, if I call my secant a u, and that's my du, therefore it becomes u to the power of 5 over 5 minus u to the power of 3 over 3 plus a c, and I'm going to have, I'm going to have a 32 here. But remember, I gave you an integral, or I asked you to find my integrand was an algebraic function right here. Therefore, I have to change this algebra, and the only thing that helped me to change the algebra is my triangle. Therefore, that becomes 32 to the power of 5. Secant is the square root of quantity x squared plus 4 over 2 to the power of 5 over 5 minus that to the power of 3 over 3. I'll let you simplify this one, and I'm sure simplification is not hard. That's another example using trig substitution. Another example I'm gonna have the square root of dx over x squared plus 16, and the radical. I don't think I want to solve this because that's easy, because that's a squared plus b squared, and this one is going to become alpha here, x in here, 4 in here, and that become x squared plus 16, and easily you can use trig substitution to solve for that. Another one it is x to the power of 5 over the square root of quantity x squared plus 2, and dx, that's the same thing. See, x squared plus 2, this is your a squared, this is your b squared, and then if I draw me a right triangle, my a is x, and this is a square root of 2, I'm going to pick that angle, and that becomes x squared plus 2. Therefore, the square root of 2 secant of alpha is square root of x squared plus 2. The tangent of alpha is x over radical 2. That's my helping equation. Therefore, my dx is the square root of 2 secant square of alpha d alpha. And x to the power of 5 is square root of 2 times square root of 2 is 2. Square root of 2 times square root of 2 is 2. 2 times 2 is 4. Is 4 square root of 2 tangent to the power of 5 alpha. And that's not very hard because this becomes secant is cubed, and that becomes tangent to the power of 5. You have to take 1 away from it and do exactly the way I did right here, and we solve for that problem. Another problem that we have is right here, is x over square root of 3 minus x to the power of 4 dx. That problem might be a little bit complicated, but I'm not scared of it because this is a negative. When it's a negative, you either have c squared minus b squared or c squared minus a squared. It doesn't matter if you call it a or a b. Therefore, my c is the square root of 3, and my b or a is x squared. Therefore, I go right here and I said this is a square root of 3, but I put my x squared right here because I want to use sign, and this is nothing except square that one. I think I did something, no, I did it right. Square that one, that's 3 minus a squared, which is x to the power of 4. I'm using that angle, don't forget. Therefore, this most difficult part is your cosine. Therefore, cosine of alpha is the square root of 3 minus x to the power of 4 over radical 3. I move my radical 3 here. How do I do your x? Oh, that's not easy. Sine of alpha equal to x squared over a square root of 3, and that becomes square root of 3 sine of alpha equal to x squared. Okay, let's go back right here, and let's not take the square root right here, because if you take the square root, then finding my dx is not easy. I'm going to find the differential of that one. Differential is the derivative times dx, and that is a square root of 3 cosine alpha d alpha. See, you do have an x right here. If you add a 2 right here, that 2 and a 1/2, that exactly on the top, it becomes square root of 3 cosine alpha d alpha. Therefore, you have 1/2 square root of 3 cosine alpha d alpha. That's all of them for x dx. The bottom is square root of 3 cosine of alpha. And see, boom, that cancels. What is left? Only 1 d alpha. And how do you solve for what function in terms of alpha is derivative is 1? Is the alpha plus c. But you got to go in here and solve for alpha. And your alpha is right here. What is your alpha? You have to apply arc to both sides. Alpha is equal to arc sine of x squared over square root of 3. Therefore, your final answer should be 1/2 arc sine of x squared over square root of 3 plus a c. I'm sorry, and that's exactly your answers. You see, sometimes you have to be patient. Don't be scared of that x. Don't be scared of a square root. Eventually, your problem is going to become nice and neat. Okay, so to do another one. Okay, we do another one. I'm going to write the next one as a x, cosecant of x, cotangent of x dx. What could we do with this? Well, in here, you have to realize you have trig function, you have algebra. And trig function and algebra, they don't combine pretty good together. Therefore, in here, I have to break them in part, and I have to do integration by part. But I know some trig function is derivative is this, except everything starts with a c, is a negative. Therefore, if I put a negative here and a negative here, that becomes the derivative of a cotangent. Therefore, if I make this one my u, which is x, and my du become a dx, and if I call my dv to become negative cosecant of x, cotangent of x dx, my v is a cotangent of x. That's simple. Then your answer is negative, bracket, uv, x, cotangent of x, minus v du, minus cotangent of x dx. Remember, your answer should become, what they do, they give you this top part or the top side of the rectangle. That side is given. You have to be able to find these two. How are you going to determine which one is x and which one is dv? In order to find those, you have to use Liate. Therefore, these represent your u. Logarithm, inverse trig, algebra, that's your algebra, trig, and so on. The minute you find your u, whatever is left is your du. And your answer is going to be this diagonal minus the integral of the bottom base. Okay, I have a negative here. I had uv minus v du, but what function is derivative is cotangent? There is not one. But I can write the cotangent as a cosine of x over sine of x, and I make this one a u, and this one is a du. Therefore, your answer is negative x, cotangent of x, minus. What function is derivative is 1 over u times du is the natural log of a u plus a c. So simple, not hard at all. It just requires some patience. Another problem that I like to do is natural log of x squared minus a 1 dx. Remember, what I see right here, I see a logarithmic function in here. And also I see a 1 here. That 1 means x to the power of 0, because everything is function of x. Therefore, this is algebra. This is logarithm. these two do not mix with one another very good. Therefore, I'm going to separate them. How do I separate them? This is my u, this is my dv, this is a given side, but I'm going to use liate to find that side. Logarithm, oh, right there is your u. What is left is your dv. But what is your du? Is 1 over x squared minus 1 times derivative of the inside function times dx. And what function is derivative is 1 respect to x, and that's x. Then your answer should be u v minus the integral of v du. And I drop my pen. I'm going to get a blue one. Therefore, my answer is going to be x natural log of quantity x squared minus a 1 minus, what is x times x? X squared. I do have a 2 here. I put x squared on the top over x squared minus a 1 bottom dx. The student said, good. How do you integrate that? Somebody said, okay, the bottom can be factored, and I'm going to do partial fraction decomposition. I said, no, sir. You cannot do partial fraction. Even the bottom can be factored. And they said, why? I said, partial fraction can apply only to proper rational function. That's not a proper. That's improper, because the power of the top and the bottom are the same. If the power of the top is less than the power of the bottom, it's proper and you can apply. But what happens if it's improper? You got to make it proper by long division. X squared over x squared is 1. That becomes x squared minus a 1. This has to be subtract. Negative times positive is negative. Negative times negative is positive. This is gone. You have plus 1. Then instead of x squared over x squared minus 1, I write 1 plus 1 over x squared minus a 1. This can be partial fraction decomposition. Okay, but I'm integrating that one, and this one is x. Therefore, my answer is x natural log of quantity x squared minus a 1 minus a 2 bracket, this is x. But I'm going to go inside and do partial fraction decomposition, integrate it, and I'm going to bring it right here. The factor of the bottom is x minus 1, x plus 1. Therefore, I put a, x minus 1, plus b, x plus 1. That has to become equal to 1 over x squared minus 1. These three denominators should become exactly the same. In order to make the same, this is short x plus 1. This one is short on x minus 1. What you did to the bottom, you got to do it to the top. Therefore, this is your common denominator right here. And this is x squared minus 1. The bottom is the same. Make the top the same. What is the top? ax plus a plus bx minus a b equal to 1. Let's compare the coefficient. This one is a graph equation of a line. But what is the slope? It's a horizontal line and the slope is 0. Therefore, I'm going to add 0x right here, that I do have something to compare with as a coefficient of x. I'm going to go right here and I'm going to factor a plus b, because both are coefficient of x. And I'm going to put my constant in the parentheses, and that should become equal to 0x plus a 1. Then a plus b should be 0. A minus a b should be 1. This is a system of equation. I add them together. 2a is 1. A is 1/2. If a is 1/2, a should become equal to negative b, and b is negative 1/2. Then, where was a? A was on top of x minus 1. Where was b? Top of x plus 1. Therefore, I'm going to write 1/2 on the top of 1 over x minus 1 dx. b is a negative 1/2, and 1 over x to plus 1 dx. And I'm going to integrate these two pieces. What is the derivative? What is the integral of that one? The antiderivative of that one? Natural log of x minus 1. Therefore, I have, remember I have a negative, I put plus 1/2 natural log of quantity x minus 1 minus 1/2 natural log of a quantity x plus 1 plus c. As a calculus student, you are required to move the 1/2 right here, the 1/2 right here, and log, the difference of a logarithm is become a quotient, and that becomes the log of the square root of x minus 1 over x plus 1, and there is an x in here, negative, that become a -2, and that become a -2, and that become a plus c, and this side you have x natural log of x squared minus 1, and I'm sure, and that's the negative, you can go ahead and simplify that one. That was another problem. I think that's good enough. This was some practice for this. Oh, let me do another one. Let me see if the other one I can do it. I don't even know if I can do it. This is this integral of sine of 3x dx. Well, you know, if this one was a definite integral, it wouldn't be hard for me because I would use trapezoid rules or Simpson rules. But right now that's an indefinite one, and I cannot use numerical approach. But remember, this is nothing except a square root of 3, a square root of x. Because when the index are the same, you can break them apart, and that become a constant, and I can move the constant out. Therefore, I'm going to move the constant out, and that becomes sine of a square root of x dx, and that's not hard to do. Excuse me? Not hard. To me, it looks hard. No, it's not, because the ugliest piece is a square root of x. Make the u to become a square root of x. Therefore, your du is, what is the derivative of that one? X to the power of 1/2 is 1/2 x to the power of -1/2, which is 1 over 2 a square root of x dx. Good job. Tell me, what was a square root of x? A square root of x is u dx. Tell me, what is dx? dx is 2u du. Oh, that was sweet. This is cube root of x. This becomes sine of u, but instead of a dx, I put 2u du. I'm going to move that 2 outside, make this one 2 square root of 3. This is an algebraic function, and this is a trig function. I can do integration by part. Here I cannot use u and a v because I have already used the letter u. If I knew I'm going to end up with integration by part, I would have called this one a w or a m or a g. But today, instead of a u and a v, I'm going to call it a w and a v. I'm going to use w instead of a u. Therefore, I'm going to say my w, and here is a dv. This is the given one, and I have to use liate to see which one is going to become my w, which one is dv. Liate means algebra, logarithm, no. Inverse, no. Algebra, yes. Algebra is u. And what is left is your du, which is the sine of u du. What is my dw? What is the derivative of u? 1 times du. What is the v? What is the integral of a sine? Is negative cosine of a u. The answer should be this minus the integral of that. Therefore, your answer should be u cosine of a u. I have a negative. Negative times negative is a positive. Cosine of u du. Okay, what is the integral of a cosine of u? Is the sine of u plus a c. Therefore, I got my answer. Tell me what was your u. My u was square root of x. There I go right here, and I said negative square root of x. I have to do some more stuff, but I'm going to do it in a minute. Square root of x. Cosine of a square root of x plus sine of a square root of x plus a c. If you remember, this was the answer to this, but also I had a constant right here, and that does not need to leave that constant out. Therefore, I'm going to bring that constant, and I'm going to put 2 square root of 3 here. Then if you want to simplify it, you can multiply it and simplify it. But that's how that problem, which looks so simple, has a function which is this long as is mother function, which the derivative of that one is this. Thank you very much and have a great day.